Hi guys, greetings from Bulgaria. In this module we are going to cover the dependency injection pattern. Until now we have covered in this course about design patterns in automated testing. We first covered the proxy and the adapter design pattern, improving the interfaces of iWebDriver and iWebElement, making our test much more stable and much more maintainable. Then we covered the decorator design pattern that help us to extend further our mini library and allowing us to write some particular extensions without breaking the solid principles. In the third video we discussed the singleton design pattern for, in certain cases, it helps us to improve the API usability, or basically how we call different page object models and other services and factories. And now in the fourth module of this course we are going to cover dependency injection. We are going to discuss two things. First, how to use dependency injection frameworks such as Unity in C#, and also we're going to cover the Service Locator design pattern. But first, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Many new videos are published each week. Also check the LambdaTest blog, because there are many detailed articles that discuss the modern test automation problems and their solutions. In the show notes below, in the description, you will find the GitHub repo with the full source code. I suggest to clone it and play along with the video. And if for some reason I'm moving too fast to particular sections of the code, just hit pause and or return. If the pace is too fast or too slow, you can always decrease that and improve the different resolutions of the video. You will find additional resources in the description below. So let's get started. First, we are going to cover what was the original problem. If you haven't watched the previous videos, I'm going to just quickly summarize the solution that we are going to improve later. With the inversion of control containers, we're going to cover many of the different related terms about the dependency injection pattern, and of course most of the time we're going to see some demos. I'm going to use an old archived project of mine with a complicated complex tool that it's using heavily dependency injection frameworks, and we are going to refactor the existing project with a few tests that it's using the adapter pattern to use the inversion of control, and we want to achieve two things. As you know, in particular projects, sometimes it's necessary to rewrite the website using a new technology, for example, converting it to be a single page application using new technologies like Angular or React. And in such cases, we don't want to completely throw away all of our tests or copy paste them and initiate this heavy refactoring. Instead, we can utilize architecture where we support two different versions of our, for example, page object models, where we define different locators and maybe if there are slight changes in the logic. But the core of our test will stay the same. So we are going to see such solution. And then we are going to discuss a related design pattern to the dependency injection frameworks. It's called Service Locator. In many instances, it's not suggested to use it, but in our case, for in test automation frameworks, sometimes when it's used with care, it can benefit us. And we're going to see how we can achieve similar plugin architecture to the one that we achieved with the decorator pattern, but in some instances it might be even simpler. So it's just another way you can pick some of them. So let's get started. First, let's cover the dependency injection pattern. Here are some terms that we need to clear first. The first one is a broader principle, the inversion of control, or in short IOC. This is a broader principle in software engineering whereby the control flow of a program is inverted compared to traditional procedural programming. In this paradigm, rather than the application directly invoking the methods of a framework or a library, the framework invokes the methods provided by the application, as you will see in a minute in the demo application that I'm going to show you. And this allows more flexible program behavior. Then we have dependency injection, or DI in short. This is a specific form of IOC, or inversion of control, where dependencies, services, objects are provided to the related component, such as a class or a function, externally, typically via the constructor, but sometimes this can be done via properties. This allows the component to perform its functions without being responsible for instantiating its dependencies and thus adhering to the principles of separation of concerns. And dependency injection frameworks, they are specialized tools for that facilitates this dependency injection. They often allow developers to define interfaces or notations, particularly in Java, that streamline the process of this injecting implementations into the components that require them. Before we fully define the dependency inversion principle, let's now discuss directly the code. This is the project that I mentioned. It's called 𝒏𝒕𝒐𝒏. This was a long time ago. This was a project that here we at Automate the Planet we maintained. It's a distributed runner that allows us to run tests on multiple machines in parallel and then merge of the results. For a few years it's already archived, we don't use it, but back in the days when there weren't so many solutions like HyperExecute, for example, the smart orchestration, we had to build our own thing. And the idea here is that it was built to be programming language agnostic, meaning that we could run distributed tests, for example, built on .NET or Java or other languages. So here, in order to build this testable architecture, I used the so-called onion architecture. It's out of the scope of this video. If you're curious, you can Google. However, the main thing here is that we have the main business logic in these core services, that it's responsible for, time distributing the tests, filtering them, achieving the history and everything. But all of the dependent, infrastructure, like working with files, directories, console, etc., they're in a separate project called infrastructure. However, we are not directly referencing the infrastructure inside our business logic. Instead, the whole idea is that we are using a lot of contracts or interfaces. And the thing that it's connecting both of them is actually this dependency injection framework. In this particular instance and in other demos, we're going to use Unity. This is a very popular open source inversion of control container framework in .NET. You can check it out. And if we look into one of our core services or the main business logic, you'll see that here we have, through composition, a lot of interfaces instead of directly referencing other related services. And as I said, many often through the help of this inversion of control containers, we are injecting them through the constructor, and we are doing that in for all of these services. And then another place that it's very important is here the main program, where we register the different interfaces to the container. Now it's time to give a definition of this inversion of control containers now when you saw some examples. These IOC containers, such as Unity, these frameworks help implementing this automatic dependency injection in the constructor, because it's not just a single class. This class can depend on other dependencies, the other dependencies can depend on other dependencies, etc. It can be a long tree of dependencies, and this IOC container manages the instantiation and provides the required dependencies that classes without the classes needing to create the instances themselves using the new keyword. With an IOC container, you typically register the types as shown here, and their dependencies up front. Here we mention, for this interface, please initialize this particular class. These dependencies can be, so a few advantages. First, objects do not need to know how to create their dependencies, which is great. This reduces the coupling between the classes and makes the code more maintainable. Then, from configuration standpoint, dependencies can be managed externally from the components that use them, often through configuration files or code-based configurations like this. It makes unit testing easier. In a minute I'm going to show you such examples, because dependencies can be replaced with mocks and stubs, and the IOC container can manage the life cycle of objects, allowing for singletons on or transient instances among other lifecycle management options. They are provided here as a separate parameter to the register type method. And then when we want to then we have this resolve. When using the IOC container, we don't need to create the objects manually. The container does it for us. This is called resolution. The container must include some methods to resolve the specified type, and the container creates an object of the specified type, injects the required dependencies if there are any, and returns the object. And also the container is responsible for managing the lifecycle of the dependent objects, and most IOC containers include, as I mentioned, different lifecycle managers. Also, you can, if you want to achieve, for example, and use the containers in multiple threads and run your tests in parallel, we can do that. If you watch the video about singleton, we took care of this there. We can use lock statements and also use child containers, but here I will keep it more simple. And I promise to show you some unit tests. Here I have unit test projects. I used a library called mock to manage these mock objects for those interfaces. But the whole point is that we isolate all of the dependencies. For example, for this particular class, we are going to create mocks for all of those dependencies and interfaces. The mock library will create fake objects or real implementation for them on the fly, using most of the time reflection, but this is hidden from you. And then using the mock framework, using mocks and stubs, we can configure the mock when the actual class and when we call some of its methods. When this class internally calls the dependency and its fake implementation, what needs to happen? In this case, I'm saying, please, when I call get all, return these fake results. Or another thing that we can do with these mock frameworks is that we can verify that particular method internally was called a few times with particular parameters. Again, this is not a video about mocking and going into these details about unit testing, but the whole point was that many often this inversion of control containers are used to achieve this loosely coupled architecture, to make it more testable, and later to allow us to write such unit tests. Of course, in automated testing, we don't care about that, because we are not going to write unit tests for our UI tests or system tests, right, or API tests. However, we can use the IOC containers slightly in a different way to help us facilitate other things. Now, if I need to finalize the terms and finalize like the definition for dependency inversion principle, here it is. Dependency inversion principle, or in short DIP, is a guideline in object-oriented design which states that high-level modules, such as, for example, this test agent run provider, this is the high-level module, should not depend on low-level modules like all of those. Both should depend on abstractions like these interfaces here. Furthermore, these abstractions should not depend on details like models and others. Rather, details should depend on other abstractions. I know that this is a little bit too abstract. Now we will go and refactor our previous solution with the adapter and see how we can achieve these two options for our page objects that will allow us to reuse our tests in case our website is rewritten. Again, this happened to me a few times in projects that we are involved, and this can be quite useful. Now, let me quickly remind you, because if you haven't watched the previous videos, I suggest to check the first one, because there I'm writing with a lot of details and explanations the test that we are going to refactor now. I tried to create a little bit more complex tests, because many often, like we discussed in the previous modules, if your code is too simple, probably you don't need to make it further more complex with design patterns. But if we want to make our tests more readable, more maintainable, and don't use, the copy pasting a lot, then we need to use these design patterns, and this is why we are creating this course. So the first test there was that we are adding a product. We are searching for a product. We are opening it. Then we are click on compare this product. Then we return. We add another product. The problem, by the way, here that we solved with the adapter that I'm going to show in a minute was that many often we had to use thread slips because this additional functionality here, depending on the server load, can take from a couple of milliseconds to maybe a second or two, and sometimes if you don't manage properly the waiting strategy, the test might fail. So basically we use the adapter to hide in a central place when we search for components to wait internally for the elements. This was one of the things that we solved. And also we extended the iWebDriver interface, as you will see, providing additional methods like, for example, wait for AJAX requests. So we are clicking compare this again, and we can add the second product, but a different one, for example this refrigerator. And when we go to the compare screen, we use model classes to verify basically whether the information here is correct or not. And through the page objects, if I need to summarize real quick what is a page object model, as you will see, is just a single class where we hold the map, or how we find all of the elements. If we need to fix it, we fix it in a single place. Also, we group all of the different actions, and in some variations like mine, we can put assertions. That's it. But with these actions, I made it more reusable. If I have other test cases where I need to verify more than 2 products, 3, 5, depending on the test case, we can do that using these generalized methods. And the second test was when we add to the cart and we increase the quantity. We click view cart, we verify the total. Again, here we are just covering the happy path. Here you can write many tests different. However, we are just filling the required information, checking the total, and that's it. And click continue and finish the order. That's our test. And now, here's the project. You can download the full source code from the links below. This is a regular NUnit project. If you're not familiar with patch object models, NUnit, check the links below. There are separate videos and whole courses about that. This is a typical NUnit project where I used and installed all required dependencies. Like I have all of the dependencies for Selenium, of course. The most important one is Selenium WebDriver. Also for backward compatibility, I added Selenium support, WebDriver Manager, and wait helpers. If you're using a version 4.11 and above, you don't need to use WebDriver Manager since it includes the Selenium Manager by default, which is downloading the driver and even provides browser management, which means that even if you don't have a Firefox, it will download a portable version. And then for the NUnit, we need these 4 NuGet packages. That's it. Then in the adapter, we have these page object models. We have a base page that contains our improved interface, the iDriver, which is part of the adapter pattern. If you haven't checked this video, check it out. But in short, this improves and allows us to add new methods to the iWebDriver interface, to this interface that it's wrapping, and also allow us to modify a little bit how the methods are working. So we added a new method start, we added a new method wait for Ajax, we renamed some of the methods. For example, instead of find element, now we have find component, and the actual implementation of the driver, it's implementing this iDriver interface. We have this factory method for this adapter allows us to control better the initialization of the driver, allowing us to control when we want to initialize it and how. Here for backward compatibility I use WebDriver Manager, but the important thing here that I implemented was that we're waiting internally in the find component every time for the element to exist before we return it, and then we wrap it in this component adapter, which is the improved version of the iWeb element, where through composition we are holding instances to the iWeb driver, to the iWeb element. We improve the interface by holding a reference to the buy locator. We wait, for example, before clicking an element for the element to be clickable, and so on and so forth. And in the page object models, as I said, we have the base class for all pages. Here, through the constructor, we are providing the interface to the iDriver. We have a reference to the different elements and how we locate them. This gives you the possibility to, if something is wrong, you can fix the locator in a single place. We also extracted different actions here, building this DSL or domain-specific language. And as I said, we improve it so that we don't need to use these thread slips. And also we have this wait for Ajax, waiting for this asynchronous behavior automatically. That's basically the adapter. Now let's see how we can use the Unity container in action. I have this version 3. Before we talk about the Service Locator, I'm going to compare them with the vanilla dependency inversion frameworks. So here now, in order to create 2 versions of our pages, you can do the following. As you can see, I created these additional contracts for all of the pages. It depends how big the change is. If it's just how you locate the elements, then probably you don't need to put all of the logic in this interface, but instead you can just move the element map or the actual components, how you locate them. However, for simplicity, I moved all of the actions and all of the assertions and all the public properties, or basically my elements. I did that for all of the pages. As you can see here, this is the checkout page. And how I did that fast, you can open the page and you can click Alt Enter, and Visual Studio is suggesting for you to extract the interface. You can press enter, and now you can, as you can see, define the new type. You can specify the name of the interface, the name of this new file, or add to the current file, but the suggested process usually to move it to a separate file. And then you can pick which properties and methods you want to move to the interface. This is how I extracted this interface really quick, and Visual Studio is doing the refactoring automatically for you. Now, how this help us? Well, in this actually, if we return to the adapter, I missed one class. This was the website class, which was the central point for our page objects. As you can see here, instead of defining them in every particular test, I have this single class responsible for initializing them once and giving us access to them. The benefit here is that when you type here the the tests, you can type website dot, and you can see all of the different pages through the autocomplete. Here you can type page and you can pick from the list. Otherwise, you need to explicitly every time define the pages on top or in a base class. So I prefer this approach. And also, if there is a refactoring like right now, instead of like here in this website, if we go, you'll see that I provide explicitly I'm creating the pages with the keyword new. But as we discussed previously, the container is responsible now for creating the instances of the dependent objects. So I refactored our website in this version 3 to use this Unity container. In order to use the Unity container, I installed this Unity NuGet package. This is the only thing that you need. Then I of course added this using. You can add it as a global using here. That's it. Then I have a private variable to the container, and as you'll see in my tests, I created the Unity container there since I registered there the driver. And here in the constructor of the website, I'm doing this resolution, or I'm creating, basically I'm getting the current instance of the driver because I registered it before, as you'll see in a minute, as a singleton. I have just a single instance of it. And then I registered my interfaces to their actual implementation. This is version 1 of my pages. For version 2 of my pages, I can change completely how they work. What I mean here is that imagine that this is my jQuery version of the website, that it's not a single page application. It has this particular locators. However, in the refactored React version, the thing that you need to do is that you need to copy. We need here to create a separate folder, version 2. I copy paste them. Then I, of course, here second version. I need to change everywhere the namespace, but as I said here, we change all of the locators like in the React. So here, if I copy this, and of course you need all of the interfaces and the web page. But the whole point is that we are going to change the locators. We are going to change the logic here. And by doing that, since we have a second version of those objects, we can register them instead. Here I can register the second version. Now, instead of using the 5th, I can copy this second version. This is the only change that I need to do later. Of course, I need to fix here the namespace of the interface. but this will change how and which version of the page my tests are using. You can have multiple versions. And if I return, as you can see here, we are registering the types. If you have a different version registered, then when we resolve them, when we get the public properties, this will return the version that we registered above. And again, the container is responsible. As you can see, previously we used the new keyword. Now the resolution is doing that for us. Also, we won't probably have a separate module about facade design pattern, but I implemented a simple facade. I wrote multiple occasions in the videos that probably you watched, some of them on the channel. I used the facade. Basically, the facade allows us to define a big workflow. As you can see here, through construction injection, I provided the dependency pages, and here I use the pages for defining one core method for purchasing products, and of course we have different parameters for achieving the workflow, and we can use the container to resolve all of the dependencies instead of defining them through the new keyword. Here is how we use them. This is the first version where we don't use the facade. Here we have a private instance to the container and to the website. We create the instance of the container, we create the instance of the adapter, we register the driver inside the container. This register instance is basically creating and registering the driver as a singleton. Then we provide the container as a dependency to the website. Since the website is responsible for registering the proper version of our page objects, this is the single place where we need to change if there is a version 2. And then the rest of the tests, they absolutely the same. Just with a single switch in a single class, we can switch from version 1 to version 2 of the test. However, we'll preserve the main workflow of the test, all of the data that we use here, and everything else. No copy pasting. If there is a change, it's only in the pages and in their version. We can support for a particular time 2 versions of the containers. That's not a problem. As I said, there are some articles about Unity that you can control that via configuration files, which can further improve our solution. And if we look into the solution with the facade, here actually we need to provide the container. We are doing the same. We are creating an instance of the container, we are creating an instance of the adapter, we start the browser, registering, and later the only thing that I wanted to show you is how we resolve the facade. You saw that the facade is dependent on our 4 objects. However, since we are using the Unity container, this dependency injection framework, it will create automatically for us all of the pages that was registered previously, and it's going to resolve properly the facade with the right instances. And now we can just directly call the facade. Lastly, I want to discuss another design pattern. It's called Service Locator. I implemented it here quickly. This is the Service Locator. We use lazy. If you watch the video about the singleton, there we discussed that this is a container in C#, a special class for lazy loading. It's thread safe by default. This is how we implemented the singleton pattern for the Service Locator. And the Service Locator pattern is a design pattern used to obtain the dependencies from a central registry. It acts as a registry that classes consult to obtain their dependencies explicitly. So how it works? In the Service Locator pattern, it provides a way to look up dependencies by a key or a type. In our case, this is the type. Like here, we need to provide the actual interface. So the client class it asks the locator for the dependency instead of creating it. So what are the advantages? First, simplicity. It is often simpler to use for small projects or single-use applications. It provides a single point of resolution for dependencies, which can simplify configuration management for simple scenarios. Again, in some instances, this might be an anti-pattern, especially if you want to achieve testable architecture. And here the key differences compared to the IOC containers. So, IOC containers use dependency injection to provide dependent objects, while the service locator is explicitly asked by the client to provide these dependencies. With IOC containers, the container has control over the lifecycle of the dependencies. In contrast, the service locator pattern leaves the control to the client, who must request the dependencies. IOC containers help to reduce the coupling by managing dependencies outside of the client code, while the service locator, on the other hand, requires the client to be aware of the locator, which can increase the coupling. This is why some people consider this in many occasions this to be an anti-pattern. And IOC containers typically offer easier testing as dependencies are injected, often through interfaces, making mocking more straightforward, while the service locator pattern can make testing harder because it may require the locator itself to be configured in the test environment. And the service locator pattern can lead to code pollution with locator calls, while IOC container keep the logic separate from the business logic. Again, since this is mini test framework, usually about the most disadvantages of this service locator, probably we don't care about them. This is why in some instances, when you are careful, this can be quite helpful. So I implemented this service locator to show you how we can extend the adapter, the place, how I extend it. If you watch the module about decorator, we added decorators for highlighting when we do particular actions for the inputs, or clicking a button, or providing toast messages and providing logging. And we did that inside these find component methods. Before the usage of the service locator, I had to modify directly every time my adapter, providing these private methods here, for example, for scrolling or for highlighting, and directly editing every time my methods. This is breaking some of the solid principles, especially the LAM that it's stating that our classes should be open for modification but closed for modification. Should be open for extension but closed for modification, which means that every time when I am doing such changes, this might trigger regression in the code that it's using my my methods, my class. This is why these plugin architectures, like with the decorators or the usage of the service locator here, can help us build these plugins. So in my case, I use the service locator instance here, the singleton, to resolve all of the plugins. I defined this iDriver plugin interface. As you can see, we have two methods, onComponentFound and onComponentsFound. And every plugin can override them, it needs to implement them and provide logic. So I created two plugins, one for highlighting. So here in the highlight element plugin, I implemented this iDriver plugin, and in the implementation of onComponentFound, basically I call the highlight method, which is using some JavaScript. We get the original background color and the outline of the element. We change it to yellow and red, and through setTimeout function we are returning it back after 500 milliseconds. And this way we can achieve this highlighting. Since we don't have an instance here for the driver itself, we can provide it as a parameter, but since I don't have it, I wanted to showcase how we use here in order to be able to execute the JavaScript, I use again the Service Locator singleton to resolve the driver and to get it from the Service Locator, and I execute the JavaScript. I did the same for the second plugin about the scroll into view. The thing that it's doing, basically the purpose of this plugin is that if you have longer pages, this JavaScript is going to scroll to your particular element, and you are going to view it on the video and also be able to perform particular actions. Here the code is much simpler. It's just this simple JavaScript. Again, we are using the Service Locator to get the instance to the driver, execute the script, and I'm doing this inside the implementation of these two methods. And the place where I actually execute the plugins is that here I resolve all of the instances, or all of the instances of the plugins that I registered in the Service Locator, and we for each them and execute their own components found, providing the current wrapped element. This is just for each them through Lambda expressions. I did the same here. Again, if you have another plugin for logging or for toss messages, as we did in the decorators, you can just register the additional plugin against the iDriver plugin, and this automatically will add your plugin. It will be executed directly here, which is excellent. This is like, you can achieve that through implementing decorator, or if you check some of my articles or if you have my books, you can achieve that through a much more complicated observer design pattern. There are other ways, but this is one of the implementations if you use the Service Locator other ways. So we walked into the in the next video we are going to cover the chain of responsibility design pattern. We are going to use it to achieve very comprehensive solution that we will add to our mini framework for troubleshooting errors if our tests are failing. So check it out, stay tuned. If you have any questions, put them in the comments below. I'll be really glad to answer. Also, if you want to hear about other design patterns that we are not going to cover, put your wishes in the comments below. And of course, don't forget to check the LambdaTest blog and to follow us on the community LambdaTest.com, and to get your free JUnit or Selenium certification and others. Thank you for watching, and see you in the other videos.